What is the energy of an electron in a hydrogen atom directly related to using the Bohr's model? Here are the concepts we will address in this video. First, events before Bohr. Second, Bohr's results. Now, looking at the events before Bohr, there are two key players in the development of Bohr's model. First, the Rutherford's gold foil experiment, which led to the conclusion that in an atom there are two regions. First is the dense region at the center that is positively charged and has a low volume. Second is the less dense region that is negatively charged around this dense center. Second is the Max Planck's conclusion that the electromagnetic radiation energy emitted by an object contains quanta, which are discrete energies. A quanta is called quantum energy, which is measured to be the product of the Planck constant, which is h equals 6.626 times 10 to the negative 34 joules per second by the frequency. Bohr in 1909 combined both conclusions to investigate the electronic structure of a hydrogen atom. First, Bohr applied Rutherford's model of an atom to hydrogen, which is a proton that is positively charged at the nucleus center and an electron orbiting around the nucleus. 1. Bohr concluded that the centripetal force acting on the electron equals the force of attraction between the electron and the nucleus. Second, Bohr had to make some modifications to the classical mechanics model of 1. For orbiting electrons, angular momentum, which is represented as L equals the mass times the velocity times the radius, and the kinetic energy E equals mv squared over 2, were considered not quantized. However, applying Planck's quantum theory, Bohr performed the 3 steps to determine the quantized energy for each n level. First, the quantized angular momentum was generated to be L equals n times the Planck constant divided by 2 pi, where the angular momentum is directly proportional to the energy level, whereby keeping the h divided by 2 pi constant. Second is experimental quantized energy values for each n value to the quantized angular momentum together. And finally, he generated the formula E equals negative RH over n squared. What does this equation mean? This equation, E equals negative RH over n squared, means the following. RH represents the Rydberg constant that is determined experimentally to be equal to 2.18 times 10 to the power of negative 18 joules per electron, and the negative sign is equal to the attraction between the positive charge from the proton in the nucleus of the hydrogen and the negative charge from the electron's orbit. Now, there are more to this. This means in the hydrogen atom, as n approaches infinity, energy approaches zero. Therefore, the zero energy results from a complete separation of the electron from the proton of the hydrogen atom, which is also known as the ionization energy. Therefore, n levels energy must be negative values. Next is that the ground state is the original orbit of the n level of the electron. In conclusion, there are 4 facts about the question, which includes the following. 1 is that energies of an electron is quantized. Second is the smaller the orbital radius, the lower the energy state, which means that a more negative energy level. Therefore, the electron's energy is directly proportional to the principal quantum number n. And finally, this explains the atomic emission spectrum and the absorption spectrum of the hydrogen atom. Therefore, the third point confirms the answer that the energy of an electron is directly related to the principal quantum number. In our next video, we will use math to determine the energy wavelength released from n equals 3 back to n equals 2.